Welcome to the wonderful world of high vacuum technology. I hold in my hand one of these beauties. It's a dual triode. I was recreating a circuit from a company called Engineering Electronic, and they made standard plugins. In this case, it's a flip-flop circuit. I bought tubes brand new out of the box, and the circuit didn't work. I spent a half an hour troubleshooting the circuit, only to find out the tube was bad. How did I determine this? Using a curve tracer. This is the Tektronix 577 curve tracer that I'm going to use to characterize some vacuum tubes. The adapter has no circuitry in it. It's a straight connection such that the emitter connector goes to cathode, base connector to the grid, and the collector to the plate. The two terminals on the front will be to the filament for the tube. The gain settings are such that vertical current per division is 5 milliamps per division. The horizontal is 50 volts per division. The series resistor for the plate is 8 kiloohms, and the max peak volts is 400 volts. The grid will be stepped in 1 volt steps, with the first step being 0 volts and progressively going negative. So 0 volt, then -1 volt, then -2 volt, and so on. Horizontally, we have 50, 100, 150, 200 volts. And vertically, we have 5, 10, 15, 20, 25, and 30 milliamps. So at 0 volt on the grid, we have 50, 100, just under 200 volts, and 5, 10, 15, 20 milliamps. The difference between 1 volt of grid change and the plate current is the tube gain. Right now I'm positioned to the left triode and the right triode. Going back and forth, you'll see a very minor difference between the two. This is a tube of the exact same type. Both tubes were brand new out of the box, but this one, as you can see, has very much lower gain. Left triode, right triode. Nowhere near the same, and yet it was brand new out of the box like the other one. The tube type is ECC 82, the equivalent of a 12AU7A. This tube did not work in the circuit. The other one did. We'll see at 20 milliamps, 5, 10, 15, 20, we have 50, 100, approximately 145 volts on the plate when it's pulling 20 milliamps. The original data sheet is about the same, 20 milliamps, 145 volts. So this tube meets specified data. And here's the final project. A stable multi-vibrator providing a clock to 4 flip-flops, making a 4-bit binary counter.